Hello students, I am Dr. Krishna Kumari, Assistant Professor, Department of Mathematics, SRM Institute of Science and Technology, Kattanguluttur. In this video, we are going to learn about analysis of variance, commonly known as Anova. Specifically, we will cover one-way Anova, two-way Anova, and how to solve problems using the shortcut method, also called the correction factor approach. This session is designed to be both conceptual and problem oriented. So by the end of this video, you will be able to understand the logic behind ANOVA, apply formulae correctly and solve numerical problems step by step. Let us begin with the basics. Let us start with one-way ANOVA. In one-way ANOVA, data is classified based on only one factor. This factor could be different missions, different workers, different teaching methods. So essentially, we are comparing multiple groups under one condition. The main question we are trying to answer is, are all group means equal or at least one is different? Now let us define the hypothesis. Null hypothesis, that is H naught. It means that there is no significant difference between the group means. And alternate hypothesis, which is represented as H1, it means that there is a significant difference between the group means. We also use some common important notations like N, that denotes total number of observations, T, that denotes grand total of all observations, CF, that denotes correction factor, SST, that denotes the total variation. And we use the relationship SST is equal to SSC plus SSE. Finally, we make decisions using the F test. So if the calculated F value is greater than the table value, we reject the null hypothesis, and similarly if the calculated F value is lesser than the table value, we accept the null hypothesis. Now let us go step by step through the shortcut method. The first step is to find N. Count all observations across all groups. The second step is to find T. Add all observations to let the grand total. The third step is correction factor, that is CF, which is equal to T squared divided by N. This is very important because it is used in all further calculations. The next step, that is step 4, is going to be finding the total sum of squares, which is abbreviated as SST. So square every value, sum them and subtract CF. Your step 5 is going to be sum of squares between groups, that is SSC. So take each group total, square it, divide by number of observation, sum them all and then subtract them using the correction factor. Your step 6 is going to be sum of squares within the group, that is SSE. So SSE is going to be equal to SST minus SSC. So this represents the variation that is not explained by different groups. So this completes the computational part. Once we compute SST, SSC and SSE, we arrange them in an ANOVA table. We calculate degree of freedom then. For column C minus 1, for error N minus C, and for total N minus 1. Then mean sum of squares is calculated. So MSC is going to be equal to SSC divided by degree of freedom, and MSE is going to be equal to SSE divided by degree of freedom. Finally, F, which is going to be equal to MSC divided by MSE or MSE divided by MSC, such that because we have to ensure that F is always greater than 1. If not, that's why we are going to take the reciprocal as MSE divided by MSC. Now we have to compare the F calculated with the F table. Now let us apply everything we have learned. So here we are given a production data of 3 workers A, B and C. Each worker has 5 observations. So the total observation is going to be 15. We are asked to test whether their average production differs significantly at 5% level. So this is a classic one-way ANOVA problem. Let us solve step by step. So first the value of N is going to be equal to 15. T is going to be equal to 270 and we are going to compute the correction factor. So CF is going to be equal to 4860 by applying the correction factor formula. Then we are calculating SST by squaring all the values. So SST is equal to 162 and then we are going to compute SSC, which is equal to 40. So far we have the total variation is equal to 162, and between group variation it is going to be equal to 40. Now SSE is equal to SST minus SSC, which is nothing but 122. So next we are going to compute the F value. So from the formula, F calculated value is going to be 1.97, and by seeing the table, F table is going to be 3.89. Now by comparing the F calculated and F table value, we can observe that 1.97 is less than 3.89. So we fall to reject the null hypothesis. So the conclusion for this given problem is going to be there is no significant difference between the production levels of workers A, B and C. Now let us move to two-way ANOVA. Here data is classified based on two factors: rows, for example some workers, and columns, for example some machines. So now we are analyzing two sources of variation. Firstly, we test the difference between column means, and then we test the difference between row means. So the equation becomes SST is equal to SSC plus SSR plus SSE. Here we are going to calculate two F values. So one for columns and the other one for rows. Let us go through the steps. So our step 1 is going to be finding n, which is nothing but rows into columns. And our step 2 is going to be computing the total, which is denoted as T. And our step 3 is going to be finding the correction factor, which is equal to T squared divided by n. So this is also similar to one-way ANOVA. And the step 4 is going to finding the sum of squares of the total, that is SST. And step 5 is SSC, that is for columns. And step 6 is finding SSR for rows. Step 7 is going to be finding SSE, that is the remaining variation. So this method helps us to understand how much variation is due to rows, how much is due to columns, and how much it is also due to randomness. Now for degree of freedom, for columns it is going to be C minus 1. For rows it is going to be R minus 1, and for error it is going to be R minus 1 into C minus 1. So since here we are going to deal with column and rows, the degree of freedom for error will be slightly different from that of one-way ANOVA. Then we are going to compute F value for columns, and then we are going to complete F value for rows. So, and then we are going to compare each with the table values separately. So, let us see the problem statement. Here we now have 4 workers and 3 machines, and they have asked us to test whether the machines differ as well as whether the workers differ. So, here they have given us 2 variables to solve. Therefore, this is going to be two-way ANOVA test. So here we have to find 2 variations, that is both on columns as well as on rows. So therefore we are going to make use of two-way ANOVA. And as of I said the steps before, so the first and second step is going to be finding the n and t value by applying the formula. So n is going to be the product of rows and columns. So in this given sum there are 4 rows and 3 columns. So the total n value is going to be 12. And T represents the grand value, that is sum of all values. By summing up all the values, it is going to be 492. And our step 3 denotes the correction factor, which is nothing but T squared divided by n. So 492 squared divided by 12, so which is going to be equal to 20163.67. And then the step 4 is going to be finding the total sum of squares. So the total sum of square is summing up all the values, square terms of all the values, and then subtracting it with the correction factor. So it is going to be 20566 minus 20163.67. So it is going to be 402.33. And then the step 5 is going to be finding the total sum of squares between columns. So here columns represents the machines. So SSC is going to be the sum of squares between the columns minus the correction factor. So the value of SSC is going to be 161.93. And the next step is going to be finding the sum of squares between the rows. So in the given sum, workers represents the rows. So similar to SSC, SSR represent the value of SSR is going to be 217. So for SSC and SSR in two-way ANOVA, we have to remember one thing. So here C represents the total number of elements that are in each row, and in the previous slide the R represents the total number of elements in each columns. So we should not put the number of columns and number of rows in SSC and SSR, but we should put the total number of elements and total number of elements in both rows as well as in columns. Then the last step is going to be finding SSE. So we know that SST is going to be the sum of SSC plus SSR and SSE. So from that equation, we can easily find SSE is going to be SST minus SSC minus SSR, which is nothing but 23.5. So by having all these values, we can find the calculated value of F by applying the formula. So here, since F should be positive, we are going to get the value as MSC divided by MSR as well as MSE as well as MSR divided by MSE. So F value calculated for columns is going to be 20.64 and F value calculated for rows is going to be equal to 18.45. So this is going to be the calculated value, and from the degree of freedom we can easily find the table value. So the table value according to the degree of freedom, table value for F at 2,6 at a 5% level of significance is going to be 5.14, and for row according to the degree of freedom, the table value for rows at F 3,6 at 5% of level of significance is going to be 4.67. Now let us interpret the results of the two-way ANOVA. We calculated two F values, one for columns that is machines and one for rows that is workers. The calculated F value for columns is 20.64 and the table value is 5.14. Since F calculated is greater than F table, we reject the null hypothesis for columns. This means there is a significant difference between machines, that is different machines produce different levels of output. Now looking at workers, the calculated F value is 18.45 and the table value is 4.76. So again here F calculated is greater than F table. So we reject the null hypothesis for rows as well. So this means there is a significant difference between the workers, that is workers' performance varies significantly. So both the factors, that is machines and workers, significantly affect the production. So by looking at the variations, that is SSC 161.83, SSR 217 and SSE 23.5, we can clearly see that the variation due to the machines and workers is much higher than the random error. So this is going to be the inference for the given sum. So the practical insight is that in real life terms, some machines are more efficient than others and some workers are more productive than others. So an organization should identify the best performing machine, analyze the underperforming machines, provide training to workers, standardizing the best practices. So the key takeaways for this ANOVA is going to be that the production output is influenced both by machine type as well as the worker efficiency, and both must be optimized for better results. So this is going to be the real life applications for analysis of variance that we are going to make use, and that's why we are studying this types of problems. So this is going to be the summary for the entire session. So now let us clearly understand the difference between one-way and two-way ANOVA. So first, going to the number of factors. In one-way ANOVA, we consider only one factor. That is, for example, we consider only workers or only machines. And in two-way ANOVA, we consider two factors simultaneously. That is, we consider workers as well as machines at the same time. And for the main objective that one-way ANOVA checks is that whether the group means differ based on one factor, and the two-way ANOVA checks whether the difference exists due to rows or whether the difference exists due to columns. So both is being checked in two-way ANOVA. and the number of F tests that is performed for one-way ANOVA is only one F test, and for two-way ANOVA, two F tests are performed, one for rows and one for columns. And the depth of analysis is that for one-way ANOVA gives a basic comparison, and two-way ANOVA gives a more detailed as well as more realistic analysis, especially in practical situations. So in real world problems, one-way ANOVA is used only when one variation matters, but in most real situations, multiple factor influences outcomes. So that is why two-way ANOVA is more powerful and informative. So one-way ANOVA is simple and limited, whereas two-way ANOVA provides deeper insights by analyzing multiple factors simultaneously. So in this session, we have learned that ANOVA is used to compare multiple group means and determine whether the differences are statistically significant, and also very important component, that is the correction factor CF is equal to T squared by N. So this is used in all sum of squares calculation. So it simplifies the computational process. That is why it plays a vital role. And we should also remember that in one-way ANOVA, we compute only SST, SSC, SSC. And in two-way ANOVA, we compute SSC, SSR, SSE, and then SST. And also, we should remember the decision rule. That is, if L calculated is greater than F table value, then we reject the null hypothesis. And if F calculated is less than or equal to the F table value, then we accept the null hypothesis. So with this, we come to the end of this session on ANOVA. Thank you all.